This video is about simplifying expressions with square roots and higher order roots, and it's lesson 46 in your book. So any number that we find the square root of has both a positive and a negative square root. Now normally when we say something such as the square root of 49 is 7, we're talking about the principal square root, which is the positive square root of the number. However, we can also multiply negative 7 by itself to get 49. So the square root of 49 is also negative 7. Typically, if no negative sign is present, we just calculate the principal square root. Now, we already know that the way that we find the square root is that we look for a number that we can multiply by itself to get the radicand, or the number under the radical. But there's actually another way to go about this. So we're looking for square roots. So for my example here, I have the square root of 64. Now what I'm going to do is I'm going to factor 64. So I know 64 is 8 times 8, and 8 is 2 times 4, and then 4 is 2 times 2. All right, and I'm going to look for squares here. So notice I've got 2 times 2, so that's a 2 squared. So those are taken care of. And then I've got another 2 times 2, so there's another 2 squared. Those are taken care of. And then I've got another 2 times 2, so there's another 2 squared. So I've really got the square root of 2 squared times 2 squared times 2 squared. Now, if I'm taking the square root of a square number, that means that my square root and my square are canceling each other out. So if I were to take the square root of 2 squared, I would get 2. And then I would take the square root of 2 squared again and get 2. And then take the square root of 2 squared again and get 2. And when I multiply all those things together, I get 8, which is the square root of 64. And that's the principal square root because we didn't include a negative sign. Now here I have the square root of 0, so I'm looking for what number can I multiply by itself to get 0. Now the square root of 0, of course, is 0, and since 0 is neither positive nor negative, we don't have to worry about a principal and a non-principal square root. Here we're looking for the negative square root of 9. So again, I'm going to factor my 9 into 3 and 3, so that's 3 squared. So I'm looking for the negative number that is the square root of 3 squared. Now my square root and my squared will cancel each other out, and I just am left with negative 3. Over here, I'm looking for the square root of 4 over 25. Now I can actually separate this fraction into the square root of 4 over the square root of 25. And when I factor these numbers, they become the square root of 2 squared over the square root of 5 squared. My square root and my square cancel each other out. On top, I'm left with 2. And on bottom, square root and squared cancel each other out, and I'm left with 5. So the square root of 4 over 25 is 2 over 5. And that's the principal square root. Again, I could multiply negative 2/5 times negative 2/5 and get 4 25ths, but we were just looking for the principal one here. Now in this case, I'm looking for the number that I can multiply by itself to get negative 36. Since I have to multiply a positive and a negative to get a negative number, there's no number that I can multiply by itself to get negative 36. So whenever I see a negative number in this radicand, I'm going to say that there's no solution or no real solution. There is a solution when we deal with imaginary numbers. That'll come later. So right now, whenever we have the square root of a negative number there, we just say there's no real solution. Not only can we take square roots, but we can take higher order roots, and they're calculated in a similar way. So if we were to take the cubed root of a number, for example, we write a little 3 in this hook in the radical. So whatever number is here, that's the root that we're taking. When there's no number there, there's an understood 2 because we're taking the square root. Here, we're looking for the cubed root of x, or the number that we can cube to get x. For example, the cubed root of 8 is 2 because 2 to the third is 8 power, so 8, sorry. So 2 to the third power is 8. The cubed root of 8 is written like this. So we have a 3 in the little hook, and then our radical, and then 8. Now, in general, if the number in the hook and the exponent inside match, you can cancel those out, and you just end up with the number in the under the radical with the power. For example, we've got the cubed root of 8, and if we factor 8, we get 2 times 4, and then 2 times 2. So then we have the cubed root of 2 to the third power. Now, the cubed root of 2 to the third power, this cubed root and this cubed cancel each other out, and we're just left with 2. So now we're going to practice finding some higher order roots. And again, these are examples that need to be in your notebook. Now our first one here is the 4th root of 81. So I want to figure out what number can I take to the 4th power to get 81. And to do that, I'm going to factor 81. So I know 81 is 9 times 9. And 9 factors into 3 and 3. And 3 and 3 over here. So I've got 3 times 3 times 3 times 3. So I can rewrite this as the 4th root of 3 to the 4th power. Notice the number in the hook and the exponent right here are the same, so the radical and the power cancel each other out, and I'm just left with 3. Now I can check that by saying, can I take 3 to this power in the hook and get the radicand? Well, 3 to the 4th power is indeed 81, so 3 is my solution. Here I've got the cubed root of 64. So I want to factor out my 64, and again I know 64 is 8 times 8, and 8 is 2 and 4, and then 4 is 2 and 2. Now I'm taking the cubed root, so I want to look for cubes. So see how I have 2 times 2 times 2? That gets me a cube. So that's 2 to the 3rd power. Those are taken care of. And then I have another 2 times 2 times 2. So that gives me another 2 to the 3rd power. And I'm taking the cubed root of 2 to the 3rd, and then the cubed root of 2 to the 3rd again. Now the cubed root of 2 to the 3rd, and then the cubed root of 2 to the 3rd. My cubed root and my 3rd power cancel out, and I'm just left with 2 times 2, which is 4. Now if I take 4 to the 3rd power, I should get 64, and certainly that does happen. So there's my solution. Here I've got the cubed root of negative 8. Now I know before I said when we see that negative under that radical, we see there's no real solution. But in this case, it's a cube. So we can actually have a negative cubed root, because if you take a negative times a negative times a negative, you'll get another negative number. So it's possible to multiply something 3 times and get a negative, but it's not possible to multiply something 2 times and get a negative. Now here I need to know what number can I multiply 3 times to get negative 8. Well, I know that if I multiply negative 2 and positive 4, I will get negative 8. And then I'm looking for other negative numbers that I can multiply to get negative 8. So I can, in order to get 4, I can multiply negative 2 times negative 2. So I'm really taking the cubed root of negative 2 to the 3rd power, because I have 3 negative 2's right here. My cubed root and my cube cancel each other out, and the cubed root of negative 8 is just negative 2. Now another way to do that would be to say, okay, what's the cubed root of 8? And then I just want to make that negative, which is still negative 2. And here I've got the 4th root of negative 1. Now if I multiply a negative times a negative times a negative times a negative, or multiply a negative 4 times, what am I going to get? So I've got a negative times a negative, which will get me a positive. When I multiply that by another negative, that'll get me a negative. And when I multiply that by another negative, that'll get me a positive. So I can't multiply something 4 times and get a negative number. It will always be positive. So in this case, I have no real solution. Now the rule here is that when the number in the hook of the radical is an even number, the number inside the radicand cannot be negative. But when the number in the hook is an odd number, it can be negative, because you can multiply a negative number an odd number of times and get a negative answer. But you cannot multiply any number an even number of times and get a negative answer. Sometimes we can write roots as fractional exponents. So in the past I've said that radicals get the same treatment as exponents in the order of operations, and this is why. So whenever we have the nth root of a number, we can write that as that number to the 1 over n power. Now, this is kind of confusing, but basically what happens is that when we have a number to a fractional exponent, this number on top is the exponent on the number. And this number on the bottom is the root that we're taking. So in this case, we have 216 to the 1/3 power. This number on top is the power, or the exponent, on the 216. So we're taking 216 to the 1st power. This number on bottom is the root that we're finding. So I'm taking 216 to the 1st power and finding the cubed root of that. So if I rewrite this fractional exponent as a root, it would be the cubed root of 216. Now when I simplify the cubed root of 216, of course I'm going to factor it. That gives me 2 and 108. That gives me 2 and 54. 2 and 27. And then I've got 3 and 9. Move down here. And then another 3 and 3. Since I'm finding the cubed root, I want to look for cubes. So here I've got 2 times 2 times 2, that's a cube. So I've got 2 cubed. And then I've got 3 times 3 times 3, so there's my other cubed. So I'm looking for the cubed root of 2 to the 3rd times the cubed root of 3 to the 3rd. My cubed root and my cubed cancel out, and I've got 2 times 3, which is 6. So I can multiply 6 3 times to get 216. All right, these examples need to be in your notebook as well. So I want to find negative 27 to the 1/3 power. Now again, this number right here is my exponent. This number right here is my root. So I've got negative 27 to the 1st power, and I'm finding the cubed root of that. So what number can I multiply 3 times to get negative 27? Now if I factor out 27, I've got negative 3 and 9, and then negative 3 and negative 3. So my cubed root of negative 27 is negative 3. Here I want to write 10,000 to the 1/4 power. Top number is my exponent, bottom number is my root. So if I'm just going to rewrite 10,000 to the 1/4 power, I know that I've got 10,000, and then my top number is my exponent, 1, and then my bottom number is the root that I am taking, so the 4th root. So I'm looking for the 4th root of 10,000. If I were to factor that out, I would get 10. Here I'm looking for the negative 256 to the 1/4 power. This one's my exponent, this one's my root. So I've got negative 256 to the 1st power, which is just negative 256, and then I'm finding the 4th root. Now remember I said you can't take an even root of a negative number because you can't multiply a number an even number of times and get a negative. So here we have no real solution.